Well, I'm delighted to be here and happy to address you. And really, this talk is part of the 101 session. It's intended not for many of you, but for those of you who are new to this field. So I don't know if anybody feels particularly brave to self-identify as being first time at this meeting, maybe first time at a big RNA meeting. You are my audience. So all the experts who could probably give this talk for me, you can take a nap or go grab a croissant or something. Seattle, have a glass of coffee, mug of coffee. So this talk really is intended for those who are new to the field to try to prepare you for the week. So we'll cover a lot of ground, but without the clicker, we're not going to get very far. There was supposed to be a clicker here. Mano stole the clicker. Okay, so what I'd like to do is take the perspective of oligonucleotides. Broadly speaking, often I'll say RNA, I really mean NA, nucleic acids. Oligonucleic acids can be RNA, can be DNA. As a new therapeutic class, that's something that we often hear, you will likely hear it in talks during the week. I'd like to just spend the brief time, 20 minutes I have with you, addressing the question of where are we? What's the progress to date? Mano set that up nicely. And then what's a prescription for how can we capitalize on the promise? Disclosure, as Art noted, I'm a consultant, and unlike I think every other speaker in this session, I have neither a boss nor a board of directors to report to, so I can really say whatever I want without getting into trouble, at least with those parties. We'll focus on product approvals, and I want to touch on some things adding to what Mano said because I think it's an important way to look at the report card. Where are we to date? How far have we come? And I'll speak briefly on the product candidate progressions. And then addressing this important question of how do we position the field for success. There's much that could be said here, and this session will touch on the 3 bullets shown there. I will touch mainly on delivery because I will be followed by speakers addressing talks and non-specific effects. The promise is tremendous. You saw this in a slightly different format in Mano's slide, and I think it's helpful to look at the central dogma as kind of an orienting principle to appreciate the vast opportunity that is presented by RNA therapeutics, oligonucleotide therapeutics. And in this depiction, you can see, starting with some of the early work focused on replacing coding content with gene therapy approaches, viral vectors, plasmid DNA, and so forth. On the right side, what I've termed here influencing processes, this covers the vast array of topics. You'll see probably all of these covered in the conference in some form or fashion. Then on the lower left, mRNA, which is a much more recent focus in the field, is kind of rounding out the picture. So you look at the totality and it covers pretty much, a pretty big chunk of biology where RNA, nucleic acid therapeutics can play an important role. So how do we bring this about? How do we make it happen? In looking at the product, what has come out of pipelines? What has emerged and what can we learn from it? This is from a review that was published by one Anna Mika, who's heavily involved in the society, has this nice figure. It came out in 2016. And you saw details on the products from Mano, but I'd like to call your attention to the dates. So the fomaversine approval was back in '98. And it was really 2016, the eteplirsen and nusinersen approvals effectively doubled the pipeline because that first product had kind of vanished. It turned out to be commercially not so impactful for a variety of reasons. So 2016, and it was highlighted here in the meeting, was a big year. It was a doubling of the RNA therapeutics that were out there. I think there are a number of lessons from that we don't have time to go into. One is that both of those are gain-of-function effects, which I think is an important thing to recognize. But when we look up to the present, 2 new product approvals really that just came within the past few months, the inotersen and the patisiran. that were mentioned by Mano. These are screenshots just from two nice, fairly objective reviews that came out in Drugs just a couple weeks ago, this month, actually. One's advanced online. And you can read about them there. They both target TTR, both. So when we back up a little bit, you know, I think to look at pipelines, it's not just a question of, well, what emerged out the other end, but how did we get to that point? And it's easy to celebrate the successes. It's appropriate to celebrate the successes. But it's also, I think, important to recognize what came before. This is a table focusing on the RNA interference only. So of that scheme I shared, this is just a small sliver. And this was published in 2012 in mTNA. Dirk Hausacker, who may be in attendance here, published this piece. And you can see there are about 20 things that were identified, INDs that had been filed back in 2012. Well, where are they today? That's the patisiran approval. Everything else is gone. I do want to note that the Alnylam PCSK9 was supplanted. This was a SNALP approach, and it was supplanted by a GalNAc approach. But for the 2012 report card, that's a pretty big attrition rate. It's something you don't hear a lot about because, you know, people don't disclose the failures. It's hard to publish papers, you know, with that as a focus. There are a lot of lessons to be learned, though, and I think it's important to be aware of what are some of the factors that lead to attrition in our field so that we don't repeat the mistakes and we position the field for maximizing success going forward. So the modality question invariably brings up the comparison with the field of monoclonal antibodies, which I think is sort of the epitome of the I want to have what she's having kind of effect in drug development. Monoclonal antibodies are often presented, at the very least, to raise money to fuel RNA programs because of their huge effect. And it is a very impressive track record, and I think it's a track record that brings lessons that we can benefit from in our field. And I want to spend a moment talking about some of those. The graph there, which comes from a 2015 review, which is free to download online, by the way, shows the product approvals in numbers, that's 0 through 6 if you can't read the legend, over a 3-decade period. And the bluish bars are ones that drop, were pulled from the market ultimately. And you can see that there are roughly 3 phases if you break it into the 3 decades, kind of the onesies and twosies. Most of those got pulled from the market. Then there's sort of this middle period where there's steady product flow, but it's not, you know, fully taking off. I would call that a consolidation phase. And then the final decade, which is definitely the full blossoming, it was the highlight of that particular review, came out in 2015. There were 47 approved monoclonals at that point in time. There were 300 in development. And it was predicted in that paper of 2015 there would be 70 by 2020. Well, if you fast forward 2017, there are actually 76. And by some counting, if you go on Wikipedia, it's 89. So this is clearly a huge home run. And if you dig into the details, they're all kind of, for those that are familiar with this space, there are a lot of different renditions, FABs and bifunctional antibodies and so forth, created to take advantage of newly identified opportunities as this technology matured. So where are we? Where are we in the nucleic acid therapeutics field? I think that it's pretty clear to me that we're in the onesies, twosies period. We're in that first phase. So that's point number 1. Point number 2, I'm not sure that monoclonals, that is like dog years, where 1 year is equal to 7 years. I'm not sure about that. But it's definitely not the same scale. That's a 3-decade phase, and for RNA, maybe ours will be 100 years. Maybe it'll be 90 years, sort of 3 years for every 1 year. I don't know. That may discourage you, but I think it's important to go back to our opportunity, you know, the landscape. The monoclonal field is in that little tiny red box. Nucleic acid therapeutics cover a much vaster space. And I think it's more appropriate to view nucleic acid therapeutics not as a modality opportunity, but of many different modality opportunities that will have different timelines with different periods of onesies and twosies coming out versus full maturity having been reached. And this is all happening simultaneously, and you'll see it in this meeting. Why is it important? I think one of the reasons it's important is a lot of the new really exciting biology isn't anywhere near the onesies, twosies phase. It's at the very, very beginning. But then other things that we'll see at the meeting are in the, maybe moving closer to the consolidation phase. And that's really important because it's really tempting to get bored in the consolidation phase. But for this field to succeed, the field has to deliver in the consolidation phase. It can't just shift to the latest new thing and live in perpetual adolescence. So the prescription. I have exactly 10 minutes to give you my prescription. Much can be done. Much of it is outside of the scope, not just of this talk, but of the meeting. And that would be the non-technical component. I would say that those of you who raised your hands, for this field to succeed, it's important to integrate new people like you. Thank you for coming. I hope that when you hear my talk that you're not discouraged, but you see the opportunity, because it's new talent like you that will help realize the opportunity in this space. Of the things that I showed on my intro slide, I highlighted delivery. So we're really zeroing in on mainly on one small but I think very important thing that has to be addressed, continue to be addressed as it has been in the past, but even more deeply and more seriously. Here's a nice figure from Steve Dowdy's review that came out last year in Nature Biotech, and it shows not just the significance of the hurdle, but also with the cargo types, the big range, that this meeting covers. On the left, you see single strand, where there is some limited bioavailability across the cell membrane. But as you go to larger cargo types, that's simply not the case. And so when you look at the product history that we want to learn from, well, the first two products, I mentioned they were gain of function. Well, I didn't mention they were simple aqueous formulations. So the chemistry that Mano outlined was very, very important in making it possible for these are the two products that were approved in 2016 to be approved without having anything super fancy, taking advantage of the prospects of some bioavailability from those smaller compounds. But then the patisiran on Petro is a double-stranded RNA. That uses lipid nanoparticle technology, as Mano noted. If you dig into the details, this is from a review that came from Dan Anderson's group. I think we're hearing from Dan tomorrow or the day after. If you look at a fancier delivery system for a larger cargo, there's a lot that has to happen. So the cargo has to make it through blood to the target organ. Liver is like the easiest target organ to pick, so we'll pick that one. Cell binding, if there's a specific cell interaction based on the design, that has to occur as hypothesized. Endocytosis, unpackaging of the cargo that was so carefully formulated to maybe self-assemble, and now all of it has to come apart at the right time. And then some fraction, hopefully, of the cargo would make it to the risk machinery in the case of RNA interference or the nucleus or other applications. That's a lot of steps that have to happen. When you look at the lipid nanoparticle technology, I'll skip this because Mano touched on it briefly, but I want to highlight that the designs behind these lipid nanoparticles, these were created, really it was an evolution of technology developed for plasma delivery. The hypothesized mechanism is more than 15 years old, and there's very little academic work continuing in this space for reasons I just don't fully appreciate. But that's point number one. Point number two is Mano didn't give the numbers on lack of efficiency. The efficiency is well below 0.1%. And so the fact that the mechanism is not well understood, I think, is extremely important for what does it mean to do better. So there are other issues. Manufacturing can be very complex and so forth. In therapeutic index as well, I want to touch briefly on this. That you'll hear the tox lecture after mine, but there are toxicities related to the delivery system. So while you're tackling the delivery hurdle and using these really interesting technologies, sometimes you can bring new toxicities to the table. Not exactly what you want to have happen, but there are some horrific toxicities associated with unoptimized nanoparticle formulations. These are discussed in this manual, a very nice handbook that came out about 5 years ago that goes through in excruciating detail of some of the cell membrane damage, damage of cellular organelles, dysfunction associated with autophagy, hypersensitivity reactions, complement activation. All of this is beyond the toxicities related to the nucleic acid cargo itself, but tightly related to, driven by the nanoparticle formulations. It can result in coagulopathy. So this is some pretty serious stuff. And then another safety illustration, not with a lipid nanoparticle technology, but with a membrane lytic technology that was developed by Arrowhead and then later discontinued about a year or two ago, that sometimes these things can blow up very late, relatively late. For research preclinical types, it's very late, meaning after millions have been spent. You can learn the bad news after you spent the money, not the way you want it to unfold. So I think that it's significant that the GalNAc technology that you saw the mechanism of a moment ago, people in the field, in the siRNA field, have voted with their feet. So Arrowhead dropped their technology where they saw that toxicity in the monkey study. They terminated their program. They walked away from their technology platform and they switched. Dicerna, this was Bob Brown's slide from several years ago, which I love the title, and we won't get into that topic right now. Silence announced that they were switching over to this, and nearly all of Alnylam's pipeline as well has opted for the simpler GalNAc conjugates. That's the low-hanging fruit, right? Why did it take 30 years to pick the low-hanging fruit? Because it's really hard. This is a hard field, and that's why I said it's important not to get bored, because 30 years, I mean, that's like a whole career. But GalNAc was floating around as a concept a long time ago, and it took a lot of hard work to get it to work. And then liver delivery is solved, and I did not see Mano's slide. This was not intended to be a direct quote from his slide, but that's what it said. I would add that identification of high-quality targets is a challenge. Why do we have 2 TTR programs? You know, we boast that we can cover the whole genome, and yet our 2 product approvals target the same thing. Target risk never goes away, you know, so all the hard work and all the milestones and achievements and so forth, we're still trying to develop drugs, and drug development is a risky endeavor regardless. And so there are certain risks associated with their programs in our field that have died, I think, because of target risk, and that is just the way life goes. All of that having been said, LNPs are not going away. They really are the main option, as far as I can tell, for mRNA delivery, a huge focus. You'll see some, I think, interesting work in this space during the week. And so all the things I said about the lipid biophysics and so forth, I think those are all super important areas of scientific endeavor that should not be forgotten. Okay, so I have about 2 minutes left. And I'm just going to throw out some things again. This is the 101. So what should you look for if you're in this space and now you're like shaking in your boots, all this scary stuff I just said? You know, it's just science. I recommend taking a scientific approach. It's worked pretty well over the decades, and I think that's the best approach going forward. Dose ranging, a lot of times people skip that. I think it's very important, even from academic groups that have limited resources. Maybe they don't know to do it at the beginning, but it's important to do it very soon after the beginning. It's not something to be skipped. Repeat dosing is extremely important. I think you'll understand why when you hear Art's talk on the immunological effects from these cargo. NHP data, non-human primate data, something that as a newcomer you may not realize that many of the delivery solutions look great in mouse. Nobody ever wants to put them in rat because they're always more toxic in rat. You just heard it from me. Write that down. You might even ask a question in one of the sessions. Did you look in rat? Did you dose to lethality? What was the dose? Go ahead, try it. Quantitative measures, that number I showed, 0.05% in one study, delivery efficiency. If you're hearing a delivery talk and it's supposed to be really wonderful, this is like a breakthrough. And they said it was 3-fold more potent. You know, 3-fold isn't really very impressive when you're at 0.05%. How about 2 logs? That would look like progress to me. So I would say think big and expect more. And then last, and this one's hard, benchmarking data. You know, oftentimes it's not something you can just go into your lab and make patisiran because they mastered making a lipid nanoparticle. You're not going to make something and match it. You may make something. You can whir up the blender and something will come out, but don't call it patisiran. What you can do is benchmark their published data. You know, so if there's dose ranging potency data in an animal model, benchmark that data. That's what I want to see. Okay, so now I have 36 seconds to be provocative. If I haven't provoked you now, hopefully this will do it because then I'm going to sit down. But I would just say that, you know, that we are seeing a new modality, I would say a collection of modalities emerging. I think that there are great opportunities in liver and CNS, and that's plenty to be super, super excited about. If the field never produced another hit, which it will, I think this would still be a smash hit. I would say that, you know, we're going to continue to see the onesies, twosies in terms of approvals. I don't think that we're, you know, we're in the end zone anytime soon. Unfortunately, I think we're going to see big failures, including big failures from tox and immunological nonspecific effects, which you're going to hear about when I sit down. And then I would say that the probabilities of success are going to vary widely across this space, and that the research and delivery will lag the biology reports, because the biology is moving at lightning speed. Almost every week there's something really, really exciting in biology, and the delivery advances simply do not occur at the same time frame. And I think that will continue. With that, I'd like to close and thank you for your attention.